this is part 2. Same deal. Let's expand these expressions. So for the first term, remember, addition and subtraction separates terms. So let's just take care of a minus 2 in brackets all squared. That's just going to be a squared minus 4a plus 4. And now we have to distribute this a into that bracket, which is going to leave us with negative a squared and minus 4a. Well, we can just get rid of our brackets carefully, like so, and then we'll have a squared minus a squared. Well, that's just 0. Negative 4a and negative 4a gives us minus 8a, and then we still have a plus 4. And please don't refactorize, that is good enough. Well, for the red rectangle, let's just rewrite this over here. We'll have 2m minus 3. However, we're going to do a slight change and just change the order of the factors. So that's going to be 2m plus 3, and then we'll have 4m squared plus 9. Now, as previously stated, when we see nearly identical factors, but the only difference is the signs, in this case, then we know we only need to multiply the first two terms inside the factors and the last two, given that the middle terms will cancel out by being 0. So for our first two terms, we'll have 4m squared, and then 3 multiplied by 3 is going to be 9. Don't leave any factors behind. By that I mean that. Well, now we see just a duplication of the exact same scenario for these first two, and that's going to end up being 16m to the power 4 minus 81. And finally we're done. Well, I think we need an eraser now to just create some space, otherwise we'll run out of aforementioned writing area. Please don't kill me, grammar police. Well, let's have a look at this one, rendered in yellow, and by that I refer to the rectangle. Well, again, this looks familiar to me, so I'm just going to rearrange the terms again. The commutative property of multiplicative or multiplication. Commutating just meaning order, I think. Please correct me, geniuses out there. Well, 3x, 9x squared is the square of that. 16y squared is the square of negative 4y, and this product is the same as the product of the terms in the binomial. However, crucially, the signs differ. Therefore, I know I only need to do that multiplication and that multiplication, which means my final answer is going to be 27x cubed minus 64y cubed. Feel free to factorize in that direction to do a double check, but that is an efficient way to save time by understanding the patterns that arise from certain products. Well, for our final expansion, let's have a look at what we have in blue. So that's m multiplied by m plus 1 over m plus 1 over m multiplied by m plus 1. Now I'm tempted to do something funny, however let's rather not. Let's just do that. So for our first arrow we'll have m squared, and then m multiplied by 1 over m. M multiplied by 1 over m, we know. Okay, anything divided by itself is equal to 1 for the m's, and 1 times 1 is just equal to 1. Well, then we find the same pattern emerging for the first arrow over here. And then we'll have a look at the second one, but 1 over m multiplied by m over there is just 1 again, as stated over there. And then 1 over m multiplied by 1 is just equal to 1 over m. Well, let's have a look, because we do have some cleanup with collecting of like terms, and I think we can finish off with another color. So we'll just have m squared plus 2 plus 1 over m, and that is that.